Over the next few video lectures, we're going to talk about quadratic equations. And we're going to talk about how to solve quadratic equations, how to find the value of x, if you will. In this video lecture, we're going to talk about how to solve quadratic equations by factoring. So our objective, solve quadratic equations by factoring and graphically. Okay, so what do we come into this lesson already knowing? We already know what factoring is. Okay, factoring is finding what to multiply together to get an expression. It's like splitting an expression into a multiplication of simpler expressions. So here's an example. The expression is x squared plus 4x plus 3. That's our expression. And if we want to factor it, we want to create a multiplication problem of two simpler expressions. Well, here we have the same expression, this case, as a multiplication of two simpler expressions. X plus 3, the quantity, times the quantity x plus 1. And each of these, of course, are called factors because factors are what you multiply together to get a product. In this case, that product is this expression. So moving from the expression to the product is called factoring. Moving from the factors themselves over to the product is called expanding or multiplying. Okay, so moving from the expression toward a multiplication problem here. Okay. We also know that the second thing we also know that's going to be applicable is the zero product property. We're going to make use of this very often. And the zero product property tells us if a product equals 0, then at least one of the factors equals 0. As a reminder, a product is made up of factors. Okay, let's define what a quadratic equation is. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and a cannot equal 0. If a equals 0, we no longer have the squared term, and it's no longer a quadratic. It becomes a linear equation. So you have to have the squared term in order to have a quadratic equation. A quadratic equation is also called a second degree equation, because the highest degree of the variable is 2. This variable's degree is 1. This is 2. The highest degree of this is 2, so it's a second degree equation. Another thing we want to note here, the form ax squared plus bx plus c equals 0 is called standard form. So when it says, write the quadratic equation in standard form, you set it equal to 0, and you put your x squared first, your x second, your constant third if it has one. Okay, here are 3 examples of quadratic equations. 2x squared minus x equals 3. X squared equals 81. And x minus 2, the quantity squared, equals 7. You can expand this, pull the 7 over, and write it in this form in standard form. Well, yeah, let's talk about solving quadratics by factoring. All right, so first, number 1, set it equal to 0. In other words, write it in standard form. Okay, step 2, pretty simple. Once it's done, we're going to factor it. Okay, we may use a common factor. We may see a difference of squares. We may have other ways, other possibilities to factor it, but we want to factor it. Once we factored it, because now it's a multiplication problem, we can now use the zero product property to solve it. And of course, everybody's favorite, we want to check our solution or our solutions. Often we have 2 in the original equation. Okay, so example 1, let's solve 2x squared equals 14x by factoring. Okay, first things first, set it equal to 0. I'll subtract 14x from both sides. And I have 2x squared minus 14x is equal to 0. All right, so now, let's see, I'll write that down. Set equal to 0. Now, can I factor it? I always tend to look for a common factor first, because that makes it, I can make it a little easier if I find a common factor. And I'll notice that 2 is a common factor to this term and this term, and that x is a common factor of this term and this term. So let's factor out the 2x. And I'm left with an x, because 2x times x is 2x squared, minus a 7, because 2x times negative 7 is negative 14x is equal to 0. So there, 2x is a common factor. I just factored it out. And now it's pretty much solved. Now it's a multiplication problem. And so I know that either this factor, 2 times x, is 0, or this factor, x minus 7, is 0. So I know 2x is equal to 0, or x minus 7 is equal to 0. That is from the zero product property. Okay, I have a multiplication problem here. Either this is 0, because 0 times anything is 0, or this is 0, because 0 times anything is 0. I can solve this one. This one says that x is 0. This one says that x is 7. So I think these are my solutions. In this case, I think I have 2. All right, let's check it. Okay, am I right? So let's check. Is x equals 0 a solution? Well, here's the original. Yes, here's the original equation. Let's substitute in C. Is 2 times 0 squared equal to, and this is a question, is it equal to 14 times 0? Well, that's pretty obvious. 0 squared is 0, times 2 is 0, and 14 times 0. So it looks like 0 is a solution. And now let's check x is equal to 7. Is 2 times 7 squared, again putting 7 back into the original equation, is 2 times 7 squared equal to 14 times 7? That's a question. We don't know until we do the math. This is 49 times 2, that's 98. And this is 70 plus 28, and that's also 98. So I feel pretty good that the answers are that I have 2 solutions to this quadratic equation, and those 2 solutions are 0 and 7. Let's check graphically. Okay, we've done this in some previous video lectures. Here's my equation. Let's just set y1 equal to 2x squared. And let's set y2 equal to 14x. And the question, when are they equal? Where do they intersect? So we're going to do a calc intersect and see. Now we think it's 0 and 7 is where they intersect. I'm going to slide this up. I have enough room there. Okay, I'll come into here. Let's see what I have. So y equals, let's clear out what I had before. So my y1 is right here, 2x squared. I know that's going to graph as a parabola. There's the parabola, 2x squared. Okay, y2 is 14 times x. That's linear. That's going to graph as a line. And I'll graph that one. And there it goes. Okay. So the line, it obviously intersects right there. So we can, let's test that out. Where is that point of intersection? So second calc intersect. I'm already right on the cursor on the origin. First curve, second curve, guess. And sure enough, x equals 0 is a point of intersection. And that one is, I'll come down a little bit. That one is right here. We said x equals 0 was a solution. Okay, x equals 7. So the question is, do these lines cross further up? I'm going to have to go up a ways to see. So I'm going to do my window. I'm going to go way up. Let's go negative 10 to 100. And I'll scale it by the distance between tick marks. I'll be 10. So there is my y equals 2x squared. Here comes the line. It looks like it does intersect right up there in the look at my first quadrant, in quadrant 1. Let's find that point. So second, let's calc intersect. I'm going to go over there. I got to be, if there's more than one intersection point, you got to move the cursor to where it's closer to the intersection point you're looking for. Okay, enter curve 1, curve 2, take a guess, and sure enough, there's 7 right there. So I do have 2 answers. One is 0 and one is 7. Just like I showed right here algebraically, when I did calc intersect, I came up with those 2 points of intersection as well. Okay, example 2. Solve x squared minus 81 equals 0 by factoring. All right, step 1, set equal to 0. Check. Okay, we want to factor this. So we want to notice here that x squared, that this is a difference of squares. I'm going to rewrite that. X squared minus 81 is a difference of squares. Okay, I have x squared minus 9 squared. 81 is 9 squared. I factor a difference of squares. Okay, I factor a difference of squares with 1 plus 1 minus. So I will go like this. X, because it's x squared. 9 and 9, because it's 9 squared, and 1 is positive and 1 is negative. I have just factored it, okay, using a difference of squares. Now I'm going to use my zero product property. Either this is 0, which means x, or this 0, because 0 times anything is 0. So x plus 9 is equal to 0, or x minus 9 is equal to 0. This one says x is equal to negative 9 or x is equal to positive 9. Okay, let's check that. Let's check it algebraically. Okay, let's check x is equal to negative 9. Is this true? Well, here's my original. So does negative 9 squared minus 81 equal 0? Well, negative 9 squared is 81 minus 81. Yep, that's a check. And now let's check positive 9. Okay, does 9 squared minus 81 equal 0? Again, that's a question. Well, 9 squared is 81. Oops, made a mistake there. And so 0 equals 0. That's good. Okay, let's do it graphically. We'll use it graphically with our zeros. Let's see here. So graphically, we're going to solve it. Now notice here that I have it set equal to 0. So I'm going to use the 0 function on my calculator instead. I'm just going to graph y1. y1 equals x squared minus 81. In this case, I'm going to use my calc zeros. All right, I think it's just calc. Let me check. I think it's just calc 0. Oh, just calc 0 and see what it is. Okay? Because it is equal to 0, so we'll look at where it crosses the x-axis. So again, I'll slide this up, pull in the calculator. Okay, let's go to y equals. Let's clear out what I had in there. I'm just going to use y1, x squared minus 81. Let's go to my, let's see here. Let's go to zoom standard. I'm not sure what's going to come out here. There, whoops, all right. Well, that's looks like it's a parabola. And if I zoom out, let's zoom out here a little bit. Zoom out. I'll zoom out from the middle. Here comes this parabola. And so you can see it's coming in. It's bottoming out down here. We're concerned about where the zeros are. Where does it cross the x-axis? So let's just do second calc. Number 2 is our zeros, so we'll choose 2. And let's go to our left point over here, left bound above the axis, right bound below the axis, and take a guess. Sure enough, negative 9 is a 0. And let's do it again, second calc. Choose 0 again. Let's go to the right side, the right place where it crosses the x-axis. Okay, below the x-axis is the left bound, above is the right bound. Take a guess. And sure enough, there's a 0 at 9. So because this equation was already equal to 0, we're able to calculate for the zeros, and we found those zeros are at -9 and 9. Again, a 0 being where it crosses the x-axis. Okay, let's do one more problem. Little more complicated, but not too bad. We're going to do a little bit more factoring with this one. Let's solve this by factoring. Okay, step 1. So we have 2m squared minus 3m minus 7 on the left. And we have 2m plus 5 on the right. Step 1, set equal to 0. So I'll subtract 2m from both sides. I'll subtract 5 from both sides. And I have 2m squared minus 5m minus 12 equals 0. Okay, factoring. This should be factorable. Okay, I like to use my my square. This one might be, let's see how this one goes here. Okay, so I know that one of these factors for 2m squared, the only thing I can do is do 2m and m. That's the only way to get 2m squared is 2m times m. So there's my 2m squared. And I need a -12 down here when I multiply my constants. And I know that these two, when added together, have to be a -5m. And so I'm looking for this up here. I'm looking for this down here. Well, to get -12, I guess I could do, I don't know, I guess I could do 6 and 2. Let's do a +6 and a -2. Okay, that's going to be +6m's and -4m's. That's not going to get -5. How about -6 and +2? That's a -6m and a +4m. Again, that's not going to get -5. I guess I could switch these. I could put the +6 down here and the -2 up here. Again, I still get the product of -12. This is a -2m, -2 times m, and a +12m. That doesn't give me -5. Let's try a +2 and a negative. This is, this just takes guessing and checking. This is +2 and -12. Doesn't give me -5. I'm guessing 6 and 2 aren't the answer. Okay, let's try 4 and 3. I'm gonna put a +3 up here and a -4 down here. I'm gonna try this. So this is +3m and this is -8m. Hey, that works. That gives me -5. This is 3m. And this is -8m, and -8m and 3m is -5m. So I know the factoring of this. This factors as 2m plus 3 from here times m minus 4 from here. Okay, now that took a little while. And sometimes it does. You get better at it as you practice, but that took some time, but we got it. So now we're going to use our zero property, our zero product property, and that says that 2m plus 3 equals 0, or, m minus 4 equals 0. Well, this one's going to be 2m equals This is going to be 2m equals -3, so m is equal to -3/2. That's one solution. And this says m is equal to 4. So we're thinking that these are our two solutions. We can always check this, put this in here, here, and here, and do the math with a calculator probably. And those two should be equal to one another. Put this one in here, here, and here, and do the math, and those two expressions should be equal to one another. Let's check it graphically. We'll check it graphically. Same thing as solving it graphically. Let's see if they do indeed intersect. If these two lines or curves, this is a curve, this is a line, intersect at -3/2 and +4. So I'm going to use y1 here because it's not equal to 0. So I'm going to set y1 and y2. So y1 is 2m squared minus 3m minus 7. That's the left side here. Y2 is the right side, which is 2m plus 5. And then, of course, we're going to calc the intersect. And we think we're going to have two places where they intersect based upon the fact that we have two answers. Okay, let's take a peek. Okay, let's go to y equals, clear out that one. My first one is 2x squared minus 3x minus 7. And as I mentioned, I'm going to go to zoom 6 standard. That's going to be a parabola. There's the parabola for equation number 1. It's a quadratic equation. They graph as parabolas. y2 is linear. It's degree 1. So it's going to graph as a line. 2x plus 5. Let's see where they intersect. Here comes the line. Well, clearly we intersect here. And it looks like we're also intersecting up higher here in quadrant 1. So we clearly intersect in quadrant 2. It looks like we intersect in quadrant 1. Let's go ahead and go up a little bit with our y's, and let's see that second intersection point. I'll go to 20. And I'll count by 5s. How about that? Okay, here comes the parabola. And here comes the line, y2. There we go. Now we have both intersections. Now let's go ahead and do calc intersect. And I'm going to look at the one on the left first, which is in quadrant number 2. So I'll move my little cursor closer to it. First curve, second curve, take a guess. Negative 1.5. Yep, that's negative 1.5 right there. Negative 1.5, same. Let's do calc intersect the second point, which is the one in quadrant 1. I'll move my cursor over to quadrant 1, closer to that intersection point. Enter, enter, enter. 4. And that's what we have right here. So it intersects at x equals 4 as well. So we know these two are the solutions to that quadratic. So there you have it. A look at solving quadratics by factoring. We're going to look at how to solve quadratics in a variety of other methods coming up in future video lectures.